how to estimate the square root of a number. So far, we know this about square numbers and square roots. A number multiplied by itself can also be written like this, a number squared. When we work it out, we get a square number as our answer. And if you've got a square number like this, it came from a square root. So what is the square root of 49? What number multiplied by itself gives me 49? 7 times itself, or 7 squared, is 49. The square root of 49 is 7. I solved this square root problem by using my multiplication knowledge. That's great if we can spot a number as a square number in our table's knowledge. But when you can't spot a square number, that's when we estimate the square root. Like in this problem, estimate the square root of 34. Explain your reasoning. Let's check it out using a multiplication chart. Here are the square numbers highlighted in blue. Notice that 34 is not one of the blue square numbers on our chart. It's not on the chart at all. That's why we have to estimate, because we can't jump straight to it with our table's knowledge. You can't get to 34 by multiplying a whole number by itself. So here's what you do. Start off by finding the square numbers on either side of our number 34. They are 25 and 36. Which numbers give us those squares? We get 25 from 5 times 5, so the square root of 25 is 5, and of 36, the square root is 6. Straight away, we know that the square root of 34 is somewhere between 5 and 6. When you do this for the first time in your math book, it's a great idea to write a note to help you understand now and for revision later on. My number is between the square numbers 25 and 36. The square root of 25 is 5. The square root of 36 is 6. So the square root of my number must be between 5 and 6. Wait, what is between 5 and 6? Not a whole number. Between any two consecutive numbers is the decimal zone. We're looking for a decimal number. It's going to be 5 point something. But 5 point what? The square root of 34 might have a string of decimal places, but estimating it to one decimal place is fine. Let's use a number line to help as we think it through. Here's my number, and here are the square numbers on either side of it. 34 is closer to 36 than it is to 25. That tells us that the square root value must be closer to 6 than to 5, and that means it has to be somewhere between 5.5 and 5.9. Now, I could just guess a number from any of these values, but I can be more accurate in my estimate if I do a trial run like this. 5.5 is halfway between 5 and 6. That gives us a square number halfway between 25 and 36. Using the number line, we can see that this would be about 30.5. It's too low. The square root of 5.5 is too small. Okay, 34 is very close to 36, so here's my estimate. The square root of 34 is approximately equal to 5.8. That's between 5 and 6 and very close to 6. This math sign means is approximately equal to, and it's great for use in an estimate statement. And I got to my estimate using only multiplication knowledge and reasoning. I didn't touch a calculator. When you have to estimate a square root for yourself, never use a calculator. Instead, use logic like I did. This will develop your understanding of square roots. Let's review. To estimate the square root of a number, you're going to use your multiplication knowledge first. Find the square numbers on either side of your number to find the two whole numbers you're working between. You can't do the estimate without this step. A ruler might help you. A number line can help you visualize the problem. You can write in sentence form too. And if you really want to impress your teacher, you'll use the approximately equal to sign. Here's a bonus idea for you. You know how we use the area of a square to find the missing side length? Well, sometimes you're going to get a square whose area is not a square number. Guess what you can use to estimate the side length? If you said this method, you've got it. Remember, think it through logically like I showed you and show your thinking. Now it's over to you. Try out some problems like this and build your math muscle.